Most people think Saturn is one of the easiest planets to imagine in the solar system, a giant ball of gas floating beyond Jupiter, surrounded by beautiful rings, almost a symbol of perfect order. But Saturn is far more deceptive than it appears. The rings are not solid. The planet has no real surface. Even its famous shape hides behaviors that don't become apparent until spacecraft begin to measure it directly. The more deeply we explore Saturn, the less it resembles the clean, familiar world shown in textbooks. Instead, it has become a reminder that reality is often far more complex than the mental models we construct to understand it. The first clue came centuries before any spacecraft reached beyond the solar system. Early astronomers noticed that Saturn's rings sometimes disappeared entirely. The planet itself hadn't changed, only the perspective had. Because the rings are incredibly thin compared to their immense width, they can become almost invisible when viewed sideways from Earth. A structure hundreds of thousands of kilometers wide can almost vanish simply due to geometry. Saturn challenged something we instinctively believe, that something massive should always be easily visible. When the Voyager spacecraft finally passed by Saturn, preserving a simple picture became impossible. Instead of neat rings, the cameras revealed thousands of narrow rings, gaps, waves, and delicate structures shaped by the gravity of tiny moons hidden within them. The rings weren't frozen decorations surrounding a planet. They were like something constantly changing, with countless particles interacting every second. Invisible gravity was creating visible patterns that shifted over time. The closer we looked, the rings resembled less an object and more a living process. Cassini changed this picture even further. After 13 years in Saturn's orbit, it revealed that the rings might not even be that old. Evidence suggests the rings may be only a few 100 million years old, much younger than the planet itself. Even more surprising is that the rings are slowly disappearing. Tiny particles are constantly falling into Saturn's atmosphere in a process known as ring rain. The feature that makes Saturn instantly recognizable is fleeting. We exist only for a relatively short period when these magnificent rings are bright enough to dominate the planet's appearance. If observers had lived much earlier or much later, Saturn might have looked entirely different. Saturn itself also refuses to conform to our expectations. We often imagine descending through clouds until eventually reaching solid ground, because that is how planets work on Earth. Saturn offers no such boundary. As you move downward, the atmosphere simply becomes denser, hotter, and more compressed. Hydrogen changes into exotic states under immense pressure, but there is no clear line where sky ends and planet begins. The distinction exists mainly because human language expects one, nature does not. Even Saturn's atmosphere is more deceptive than it appears. Compared with Jupiter, Saturn often looks calm through ordinary telescopes, yet observations have revealed enormous storms capable of wrapping around the entire planet. Roughly every Saturnian year, about every 30 Earth years, a massive atmospheric disturbance erupts, releasing extraordinary amounts of energy before gradually fading away. For centuries, humanity never witnessed one simply because they occur so rarely. Sometimes, reality stays hidden not because it is impossible to observe, but because it demands more patience than a single human lifetime usually allows. Then there is Saturn's North Pole. Sitting above it is a nearly perfect hexagon, nearly 30,000 kilometers across. Despite powerful winds racing through the atmosphere, this geometric pattern has remained remarkably stable for decades. Laboratory experiments suggest it forms naturally within rotating fluids, meaning no new physics is required to explain it. Yet it still feels strangely unnatural. We expect turbulence to erase order, not create it. Saturn quietly reminds us that nature has no obligation to follow our intuition. Its magnetic field presents another puzzle. On most planets, the magnetic field is tilted slightly away from the rotation axis, making the planet's spin relatively easy to measure. Saturn's magnetic field is almost perfectly aligned instead. That remarkable symmetry actually makes determining the planet's exact rotation much more difficult. The planet is spinning exactly as expected, yet one of our best measuring tools becomes far less useful simply because the magnetic field is too perfect. Once again, the problem was not with physics, it was with our assumptions about how measurements should behave. Cassini also discovered that Saturn's visible cloud bands are connected to atmospheric flows extending thousands of kilometers beneath the surface. What appears to be shallow weather is actually linked to motions deep inside the planet. The atmosphere and the interior are not separate systems, but parts of one enormous, continuously connected world. Even Saturn's interior is becoming less certain the more accurately we measure it. For decades, scientists imagined a dense, compact core hidden beneath the planet's deep layers. Recent analyses of Cassini's gravity measurements suggest something far stranger. Instead of a sharply defined center, Saturn may contain a diffuse core where heavy elements gradually blend into surrounding hydrogen over tens of thousands of kilometers. Rather than resembling a planet built around a solid heart, Saturn may be more like a world whose interior slowly fades from one state into another. Once again, the neat boundary we expected simply is not there. Saturn's moons continue the same story. Enceladus, a small icy moon, ejects giant plumes of water vapor from an underground ocean hidden beneath its frozen crust. Cassini flew directly through those plumes, detecting water, organic molecules, and evidence of hydrothermal activity. One of the smallest moons in the solar system suddenly became one of the most interesting places to search for conditions that could support life. Titan, Saturn's largest moon, offers another surprise. It has rivers, lakes, clouds, rainfall, and coastlines, but they are made not from water but from liquid methane and ethane. The landscapes look strangely familiar even though the chemistry is completely different. The shapes remain recognizable while the materials creating them have changed entirely. By the time Cassini ended its mission with a deliberate dive into Saturn's atmosphere, the planet had become something very different from the simple icon most of us imagine. The rings were no longer permanent. The atmosphere had no clear boundary. Hidden storms, unusual geometry, and almost perfectly symmetrical magnetic field and extraordinary moons had replaced the neat picture found in children's books. None of these discoveries overturned science. They simply revealed that the simplified version we carried in our minds was never the full story. Perhaps that is Saturn's greatest lesson. The universe rarely deceives us. More often, we deceive ourselves by believing that familiar shapes must have simple explanations. Saturn still looks like the most recognizable planet in the solar system. We just know now that almost everything making it recognizable is far stranger than it first appears. And if something as familiar as Saturn can become almost unrecognizable once we measure it carefully, it is worth wondering how many other parts of the universe only seem simple because we have not looked closely enough.